Okay, today we're going to go ahead and start looking at solving absolute value inequalities. So let's go ahead and start off with an equation, and let's see how this solution looks. So we've already learned how to solve an equation. Okay, we know that inside the absolute value could be 3. Absolute value of 3 is 3. Or I should say, and x could be negative 3. Absolute value of negative 3 is 3. Going back to our definition right here, x could be positive or x could be negative. In either case, you're going to end up with a positive answer. Okay, so graphing this, of course, we would put a closed dot at 3 and another closed dot at negative 3, showing our two solutions on a number line. Okay, so here we have our first inequality. We have the absolute value of x is greater than or equal to 3. So, looking at this one, we're going to have a different condition here. So the first inequality that we're going to set up when we have a greater than is basically the same thing. X is greater than or equal to 3. So at 3, we would have a closed dot and we would shade to the right. The second inequality that we would set up here is we would have x is less than or equal to negative 3. Similar to what we had here, 3 and negative 3, except since we applied the negative here, we had to change the greater than to a less than symbol. And so the solution could be greater than or equal to 3, or less than or equal to negative 3. And there's your shading to show that solution. Okay, in this case here, we have the absolute value of x is greater than or equal to 3. So to set this one up, we set it up a little bit differently. We want x to be less than or equal to 3, but greater than or equal to negative 3. Notice in this example where there's a greater than, we shaded towards away from our two solutions. Well, I should say our solution starting points, 3 and negative 3. These are all solutions, infinitely in both directions. Here the solution is going to be located between those two numbers. And so we would shade in between. So all the points from negative 3 to 3 would be solutions of this problem. Very important to remember. Greater than, you're shading on the outside. Less than, you're shading on the inside. Okay, let's go ahead and look at some examples. Okay, so taking a look at this example here, the first thing I want you to notice is how the absolute value is, there is nothing on the outside of it, and that's very important. That before you do what I'm about to do, that you make sure you clean up the outside, undo any adding and subtracting, undo any multiplying and dividing, make sure that all you have here is an absolute value with an expression inside. Okay, so first thing we're going to look at here is, since it's a less than, we're going to follow this example right here. Okay, so notice how we set this up. And notice that we have two inequalities. This is called a compound inequality. So that's what we're going to do. We're going to set up a compound inequality. But instead of just an x on the inside, we have 2x plus 3. Okay, and so that's going to go in the middle. And we're going to bring down the less than. Notice this one does not have an equal. So that means that our two endpoints are going to be open dots and not closed. So we're going to go to 15 on the right side. Okay, notice the symbols are the same, so we're going to keep the symbol the same, less than. And then we have the negative 15 on the right. So look back and see how these compare. Okay, let's zoom here just a little bit if I can. There we go. And now we're going to go ahead and solve this compound inequality. So we actually have two inequalities here that we're solving simultaneously. This one on the right, this one on the left. Okay, so the goal here is to isolate the x, just like we would when we solve an equation. We want to get x by itself. So we want to get x by itself in between the two inequalities. So the first thing, as usual, we would undo adding and subtracting. Now, you may have seen prior where we would draw a line. That's just to help us to know that, hey, we have two different sides to this inequality. So if we do it to this side of this line, we have to do the same thing on the other side. And the same thing over here. If we subtract 3 on this side, we have to subtract 3 on this side. Okay, remember there's two inequalities here. So if we were just solving this, we'd have to do this. If we were just solving this, we'd have to do this. Okay? All right. So now we have just a 2x in the middle. And so, as you know, we would undo multiplication with division, do it to each side. All right, so now we have negative 18 divided by 2, which is negative 9, is less than x, which is less than 6. So if we were to graph this solution, we would put our 0 on our number line, count out to 6, count left to negative 9, and since there's no equal part, we'd have open dots. And the shading is going to be between negative 9 and 6 because the solutions are between negative 9 and 6. X is, if you're reading it this direction, x is greater than negative 9. That's going this way. X is less than 6. If you want to test your answer, you'd pick a number between negative 9 and 6. So let's choose 0. That's always an easy number. So if I test a point, let's test x equals 0. So plugging it in to our original inequality, we're going to get 0 plus 3, which is 3. So we'd have the absolute value of 3 is less than 15. Absolute value of 3 is 3, and that checks out. Okay, let's take a look at another example. Okay, let's take a look at example 2. Again, I'm starting off with the absolute value nice and cleaned up. In other words, there's nothing on the outside, on the front, or on the back, which we would need to clean up first before we do this next step. So when you look at this, it's a greater than symbol. So looking back at our 3 examples, this is the example that we want to follow. So we want to set what's inside greater than or equal to the positive value. Okay? Or we want to set what's inside less than or equal to the negative value. Okay, so following this model, we're going to take what's inside, okay, and set it greater than or equal to the value, which in this case is 5, 6. So that's going to be 1 that we're going to solve. So let's go ahead and solve it before we set up the second one. So remember, to cancel out a fraction, we would want to multiply by a common denominator. So a common denominator here would be 6. Don't forget that if you ever multiply or divide by a negative number, the inequality flips. But in this case, it's a positive number, so we're good. So 3 goes into 6 2 times. So we're going to have 2 times 2x minus 1 is greater than or equal to 5. Distributing the 2, and then solving for x. Basic solving. Okay, so this is going to be one of the solutions to the inequality. Okay, or now let's set up the second one. So the second one, recall, is where what we take inside the absolute value, the expression inside the absolute value, and we switch the greater than to less than, and we change the sign. And that's when we change the sign, that's why that flips, remember. Okay, so let's go ahead and set this up. So we're going to have 2x minus 1 over 3. Notice that when we set these up, the absolute value goes away. We take what's inside the absolute value, and the absolute value goes away. Okay, and so this is going to change to less than or equal to, and we're going to use negative 5, 6. And now we're going to solve this inequality. So again, we're going to multiply both sides by a common denominator to cancel out the denominators. 3 goes into 6 2 times. 6's cancel, leaving us with negative 5. All right, so distributing the 2, and then solving for x. So our second solution is x is less than or equal to negative 3/4. All right, so let's see what this looks like on a number line. Remember the previous example, the solutions were found between, and so this one, since it was a greater than, the solution should be on the outside. So let's go ahead and do that. So we're looking at x is greater than or equal to 7/4, which is 1 3/4. So we're talking about this is 1 and this is 2. We're talking about right here, a closed dot at 1 3/4, and we're shading greater than. It's equal, so it's going to be a closed dot. Go in the other direction. Negative 3/4, which is going to be about right here, and we're shading less than that. So this is an or statement. This is an and statement. X is less than 6 and x is greater than negative 9 in between. Okay, come with your questions tomorrow. I'll see you. Hope you're having a good evening.